Classical cryptography, in times of war. Enigma. Inside the Enigma. Let us have a look at the inside of the Enigma. For our example, we start with the case where we only have 4 letters on the keyboard, 4 light bulbs, no rotors and no plug board. This means that we have a direct connection between the keys and the lights. If we press for instance the key E, a switch is flipped and the current can run through the light bulb, which now shines. Let's insert the first rotor. There were 26 electrical contacts on each side of the rotor, where one contact stood for one letter. Hence, we have 4 contacts. One contact on the right was connected to one contact on the left by an insulated wire within the rotor. Note that the contacts were differently wired. Otherwise the use of the rotor would not have made any difference. If the key E is pressed, the current now runs differently due to the rotor. Hence, the light for the letter N shines, instead of the light bulb for E. As a next step, we want to see what happens if we rotate the rotor. For this, we color 2 wires. Red connects key E with light N. Green connects key N with light I. Let's rotate the rotor 1 position. We see that the red and the green wire now connect different cables. Again, we press key E, and look how the current runs now. While up until now, light N shone for key E, now light G shines. This demonstrates that the encryption of the same plaintext letter changes according to the position of the rotor. If you want to learn more about the cryptography and other interesting topics, go to embeddedacademy.com.